How do submarines stay underwater for months, sometimes half a year, while carrying hundreds of crew members who need oxygen, water, and food? To understand just how far we've come, consider this. The world's first combat submarine could barely survive 30 minutes underwater. It had no engine, no oxygen system, and not even a targeting device. Once the air ran out, the crew had no choice but to surface. Over the next 2 centuries, navies around the world tried every method imaginable just to stay submerged a little longer, but they always ran into the same wall, and submarines were forced to surface after a short time. That all changed the day humanity invented the nuclear reactor, because the nuclear reactor solved one thing completely: the power problem. Every nuclear submarine carries its own nuclear reactor. Inside that reactor, precisely arranged enriched uranium, 235 fuel rods are bombarded by neutrons, causing some atomic nuclei to split apart. This releases enormous heat and even more neutrons, which go on to split other atoms, creating a continuous chain reaction that generates incredible amounts of energy inside the fuel rods. That heat is used to boil water into steam. The steam flows into a turbine system, spinning the turbines, which ultimately transfer power to the submarine's propeller. A nuclear submarine barely needs to refuel at all. Once it enters service, the fuel it carries can last more than 30 years. So as long as the system runs stable, theoretically, a submarine never needs to surface. But there's still the matter of oxygen, water, and food. With nuclear power on board, solving the air and freshwater problem turns out to be surprisingly straightforward. Oxygen is generated by electrolyzing seawater, because water itself is made of hydrogen and oxygen. First, seawater from outside is filtered, pressurized, and purified through a desalination and deionization process. It then flows into an electrolysis unit containing 2 electrodes, one positive, one negative. When electrical current passes through, the water splits into hydrogen gas and oxygen gas. The positive electrode releases oxygen, which is piped through ventilation systems to every compartment on the submarine. The hydrogen is safely discharged into the surrounding seawater. Just like that, breathable air solved. Fresh water is handled through a distillation unit. Seawater is heated until it evaporates, leaving behind all the salt and impurities. The steam is then condensed back into liquid, clean, drinkable fresh water produced directly from the ocean. That just leaves food, and food can only be solved one way: you load it before you leave. A typical 3-month mission, feeding around 130 crew members, requires carrying close to 2 tons of supplies. Most of it is canned goods, dehydrated food, and vacuum-packed meals. But space inside a submarine is incredibly tight. Under the beds, beneath deck panels, even across the floor of the torpedo compartment, every available inch gets stacked with food. And once the food runs out, the mission has to end. So what actually limits how long a modern nuclear submarine can stay out is no longer fuel, it's food. There's one more thing: the psychological pressure on the crew. A long patrol means weeks or even months completely cut off from the outside world. No sky, no sunlight, no wind, no rain, just artificial lighting, recycled air, and the constant low hum of machinery. To maintain stealth, crew members use silent exercise equipment, watch movies with headphones on, and keep their voices low at all times, because every dropped wrench and every slammed door could potentially give away their position. But this is the reality that crew members must accept, because a nuclear submarine truly is something unlike anything else on Earth.